Hi, sir.
Hi, good evening to all.
Good evening, sir.
Good evening, sir.
So, the video I sent you, could you please explain how that works?
Induced electromagnetic induction. It induces EMF in the loop.
So, what does the battery do then?
Battery produces a current. Self-induction opposes that.
Oh, yeah. Yes, sir. Got it.
Do we have OD1 kits as well in this group?
Yes,
OD1
sir.
and OD2, right?
Yes, sir.
Right. So today, categorically, we will be solving HCV doubts and classical magnetism assignment 1. Right? Monday evening, probably I'll put the second doubt lecture for the 2 other assignments and the booklet. Right?
All right, sir.
The reason being OD2 बच्चों को assign classical magnetism का assignment 2 दिया नहीं है या आज ही खत्म किया उनके लिए वो classical magnetism, oscillating magnetometer, deflection magnetometer, time period, all that I covered today. So I'll have to give them time.
सर आप 3 ईयर में थर्ड असाइनमेंट भेज दोगे?
ये क्लास होते ही भेजूंगा बिकॉज सेल फोन में ही है. राइट, फर्स्ट ऑफ ऑल 1 मिनट को HCV खोलना पड़ेगा.
सर पहले असाइनमेंट डिस्कस कर.
पहले असाइनमेंट कर ले.
सर हमारा HCV हो गया एक्चुअली.
ये कौन सा बैच का बच्चा है?
सर 3 इयर्स.
हाँ सर, अंधेरी 3 ईयर का हो गया है HCV.
HCV असाइनमेंट क्लासिकल मैग्नेटिज्म 1 डिस्कस करूंगा.
ठीक है सर.
सर वो सेकंड वाला नहीं करोगे?
नहीं करूंगा बिकॉज द अदर बैच OD2 वालों को अभी अभी दिया हुआ है असाइनमेंट. आज ही खत्म किया है OD2 का.
ओके
That's why I
सर.
wrote in the group also only this will be covered.
सर चलेगा.
क्लासिकल मैग्नेटिज्म में जहां तक मैं जानता हूं आप लोगों के लिए डाउट्स नहीं होंगे.
हाँ सर, वो सेकंड
सर वो बार
असाइनमेंट
मैग्नेट वाला है क्या?
हाँ,
हाँ
सर
हाँ.
उसमें एक ही क्वेश्चन डाउट.
एक ही क्वेश्चन डाउट है तो रुको खोलता हूं. हाँ, खुला हुआ है. असाइनमेंट 1 ये खत्म कर ले. असाइनमेंट 1
सर क्वेश्चन 8.
The bar magnet is bent in this particular form. This is the north pole and this is the south pole. If this is R and R, this will be R root 2. Now he says bar magnet of dipole moment capital M is bent in the form of small m into 2l. This is 2ln. Pi R by 2 should be 12. Am I right? This length will be 2 pi r is the total length. 2 pi r by 4 is pi r by 2. So do I get r 4l by pi? Substitute this r here. So now the new dipole moment m dash is small m into this distance r root 2. Small m into r is how much? 4l by pi root 2. This is M dash. This is M. Divide both, I think you will get the answer.
Sir, I by mistakenly took a semicircle.
सुना ही नहीं दिया.
सर वो गलती से सेमीसर्कल ले लिया था इसलिए आंसर मैच.
This assignment is easy, relatively. JEE mains level. This is classical magnetism. JEE mains का ही था. So this will not create trouble for you. Your trouble will be the second assignment or magnetism ka assignment. That I didn't cover for the other batch. Hence Monday evening, 99% I'll have the doubt lecture with that. I'll send the link for you people also. Is my video lagging by any chance?
Yes.
Yes,
sir.
sir.
Yes, sir.
थोड़ा.
एक second रुको. Now the problem should be resolved. Can I rub the board?
Yes, sir.
Assignment 1 में कुछ और doubt?
So for the fourth one, I think I may be going wrong, but could you just repeat it once?
एक second. By mistake I closed the assignment. Fourth. Okay. Fourth, the easiest way will be whenever they give you this, even in electrostatics, we told you this. Whenever there are two, find out the resultant dipole moment. You have two dipoles here. Right? This is north, this is south. You will have one dipole moment M1 like this. This is north, this is south, another dipole moment M2 like this. Resultant dipole moment M will be root over of M1 square plus M2 square. So एक ही dipole आ गया. You have one vector this way, one vector this way. The resultant dipole will be like this of capital M. Right? This will be south, this will be north. You are asking me for the net dipole moment at this particular distance. And what distance did he give you? Both are identical dipoles. So this will be M times root 2. This will be making an angle of 45 degrees with both. This will be making an angle of 45 degrees, which actually matters not. You want the magnetic field along the equatorial line. Broadside on position. At what distance is he asking? At a distance of d. Broadside on position. Mu naught capital M by 4 pi d square plus L square to the power 3 by 2. L is very small when compared to d. Mu naught capital M by 4 pi d cube. Here what is capital M? Capital M root 2.
Okay, sir. Thank you.
Sir, sir, in tomorrow's lecture, will you also cover the HSC part of wave optics?
नहीं होगा यार. Because some students ask for diffraction polarization. अब communications भी करना है, polarization करना है, diffraction कहाँ तक होगा पता नहीं.
सर पोलराइजेशन ARP सर ने कल ही पढ़ा दिया.
भाई साहब आपके बैच के लिए होगा. किसी और बैच में फ्लैगशिप 2 या 1 के बच्चों ने मैसेज किया है वी नीड डाइफ्रैक्शन एंड पोलराइजेशन. मैंने हाँ बोला हुआ है. तो पहले कम्युनिकेशंस करूंगा, उसके बाद डाइफ्रैक्शन पोलराइजेशन करूंगा. टाइम मिलेगा तो कुछ और करूंगा, मगर टाइम मिलना मुश्किल है. आई विल नॉट रेज फॉल्स होप फॉर यू.
Okay, sir.
Can I close the assignment sheet?
Yes, sir.
Yes, sir.
Fine. We go back to HCV, but 1 second, I am searching this book HCV. Either I misplaced it or my daughter started studying. कुछ तो गड़बड़ है. Book is missing. 1 second, रुको. I will bring the book. Wait. Yes, I have the book HCV with me. Firstly, magnetic field. Magnetic field. $29, $43, $42, $45 C and D. This is what is typed till now.
Can you do the 14th one?
14,
12th one.
So 18.
So 13th one, not 12th.
21st and 22nd also. 44th.
38.
And 61st.
fine. We start with the 13th question. Class notes. Not fair. This is the ring. This is of radius A. There is a hypothetical magnetic field like this. B naught ER. So here the force will be dF like this. FBI. If magnetic field was along my forefinger, thumb would have been the force. But here the force is in this direction. Right? So if this is theta, this is theta, this is theta. This is dF cos theta, this is dF sin. This dF cos theta and this is dF sin theta. All dF cos theta components will cancel out. All dF sin theta components will add up. Are you able to recollect this? Have we done this in the class?
Yes, sir, we are done.
जिसका भी डाउट है फर्दर सॉल्व करना है या हो सकता है in this mad rush I might have forgotten in some batch as well. If I have forgotten, please let me know. I'll solve it.
No, sir. Rectangular wire loop, suspended magnetic field, current in the loop, reversed. What did he ask? Magnetic field exists in the lower region. Find the change in the tension of the spring. The current in the loop is reversed. Or initially current is in anti-clockwise direction. You have a loop like this. Current is in anti-clockwise direction. This is outside. So on this it is FBI. It is crossed. FBI. So this was BIL. So net total tension in this was mg minus BIL. Now if I make it clockwise, current in this is reversed. Now I am making current clockwise. BIL will be in the downward direction. So the tension in the spring is mg plus BIL. Doubt क्या हो सकता है इसमें? Only thing when students have a doubt is they are unable to recognize that this part is outside the magnetic field. That's all. But for that, there is no other confusion in this. Tell me when I can rub the board.
So done.
18. Once again, done in the class. This is a sine curve. There is current in it. You have a magnetic field. Close the closing side of the sine curve this way. If this is I, this will be BIL. Force is BI lambda. Right? Force on the sine curve will be equal and opposite. Force on the sine curve plus force on BIL, sum total should be 0. BI lambda.
So done.
21. Current is in this direction. 21 में doubt क्या है ये? Battery resistance, you have a dot magnetic field. Right? Magnetic field value is given, weight is given, PQ of length 20 centimeters. 2 wires PQ with the battery are loose and exert no force on PQ. Find the tension in the thread when the switch S is open. When the switch S is open, it should be only because of mg. When the switch S is closed, your force is on PQ. Current is in this direction. Dot is outwards. I dot is outwards. Force will be in this direction. mg plus BIL is in this direction. This will be T and T. This will be T cos theta, T cos theta. So Tt 2T cos theta is mg plus BIL. If mg is 0, make it 0. If it is not 0, add them up.
So done.
22nd. 22nd में on this metal strip you are producing current. The force on this will be BIB. This length is L. You know there is a magnetic field and you know current. Current is in this direction because of the battery and the switch, and you have a magnetic field outwards. So FBI 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 force. Thumb is the force, forefinger is the magnetic field, middle finger is the current. So this is the direction of the force. This is the force acting. With what velocity will it reach this particular point? V square is equal to U square plus 2AL. Initial velocity is 0. B by M into L will be V square. Now with this velocity it will fall on the ground. How much distance will it move before it comes to rest? Mu mg is the frictional force. Distance moved, negative. Final kinetic energy is 0. Half mv square. The distance it moves from here before coming to rest is yes. Now S is what you are asking me. This v square you substitute here, you get the answer. The slider slides from here till here. So this is the velocity with which it is falling on the ground. After falling on the ground, how much distance will it move before coming to rest because of friction? Final kinetic energy minus initial kinetic energy should be work done by friction.
So could you repeat what you just did in the last step?
Pardon?
Could you repeat what you did in the last step, sir?
The slider falls on the ground.
Uh,
There is friction on the ground. The slider is falling with some velocity on the ground. So it will travel some distance and come to rest. How much distance? Work done by friction is mu mg into displacement. Should be equal to change in kinetic energy.
Yes, sir. My 0 minus half will be sir. Okay.
$29. Listen, I don't know the directions given in 29th, but I'll explain the concept. Motional EMF, when I explain this Hall effect. I don't know if I missed in any batch. Current is flowing in this direction. So positive charge is moving along the duster from my side to your side. Till here, everybody okay?
So,
Now magnetic field is vertically upwards. FBI. Magnetic field is my forefinger. Middle finger is the direction of current. See the direction of the thumb. So positive charge will experience a force such that they deposit on this side of the duster. Negative charge will experience a force such that they deposit on this side of the duster. Yes or no?
Yes, sir.
So now the magnetic force acting on it is BQE. The established electric field will establish a force of EQ. So EQ will be equal to BQE. Because of the magnetic force, positive charge is accumulating here, negative here. And the electric field is establishing in the opposite direction because of the accumulated charge. As the accumulation continue, electric field will be increasing. At some stage, both will be equal. E will be equal to BV. Motional EMF is BLV. Or here Hall EMF will be BLV. L will be the width. So don't call it L, call it the width B. The width, the potential difference across this is Hall effect. This happens not because of the motion of the conductor. This happens because of current. If it is because of the motion of a conductor, it will be motional EMF. Here it is because of the current. Hence it is Hall effect. The question is all the more self-explanatory if you people read the question. बड़ा question देख के डर जाते हैं. 38, 38. This is theta. We have done this if I'm right. B, F, B, I. Force will be this way. So it will take a turn and it will come out like this. How much time does it spend? This will be theta. This will be 90 minus theta. This is theta 90 minus theta. This is 90 minus theta. How much time does it spend inside the magnetic field? Should not be difficult for you. For 2 pi, it was 2 pi m by bq. Here, what is the angle subtended? 2 into 90 minus theta m by bq. This will be the time it spent inside the magnetic field. And if it were negative, the particle would have turned this way. Now this will be the angle. Kya hua hai ye? Yes or no? If this
Yes,
is
sir.
theta 90 minus theta, this is theta. Once again, the same logic. Here only difference is you will take this angle. In the place of 2 pi, you will take this angle. The time it's spent inside the magnetic field.
So done.
Forty-two. 42 में it's a game of numbers. You have a magnetic field here. Particle enters this way, takes a turn. From here it goes straight. This is theta. This is theta. Right? बाकी सब तो it's a straight hit. Suppose I take this particular point. This will be theta. This thickness is d. This is y. This is capital D. Tan theta is y by capital D. Sin theta d by r. Sin theta is d by r. D by mv by bq. Sin theta is d by r. R is mv by bq.
So done.
43. 43 में this is the particle is going this way. Consider this to be the object. You know the object distance. The particle is going in a circular track here. The radius will be taken as an object. Consider the radius to be an object. You know the focal length. 1 by f is equal to 1 by v minus 1 by u. This will be the radius. You get v, so I'll get the size of the image I by u. I know magnification is v by u, so I know I by u as well. Magnification is v by u, so I know I by u as well. I'll get the radius. 44 May, you have a gun here and it should join here. So technically it should go in this particular form. Helical path, see this angle is theta. This is the magnetic field. Once the particle makes an angle of theta with the magnetic field, velocity makes an angle of theta. It's a helical path. Once it is a helical path, this distance x should be n times the pitch. X should be n times the pitch. N times v cos theta into time period 2 pi m by b. Now, if you want b to be minimum, then put n equal to 1. And in the last step, substitute theta tending to 0 because he says they're deflected at very small angles theta. C and D. What instant will they collide? 45 May. I tell you at what instant they collide. You will do the balance part of the problem. Have a look at it. This is Q and M. This is minus Q and M. Separated by a distance of 2D. 2D or D. He gave D. So this particle will move this way. This particle will move this way. Because this will be FBI. For a positive charge, the force here would have been downwards. Because it is a negative charge, force is in the upward direction. Now, you don't want them to meet. They should come this way. The radius of the two particles should be greater than D. 2R should be lesser than D. 2 times mu by dq is lesser than D. So U should be lesser than dq d by 2x. Agreed? U should be lesser than dq d by 2n. Now the second point here. What if U is equal to 2 times dq d by 2n? That's what he has given. What if U is 2 times this? By the way, did I calculate dq d by 2n correctly? Yes. If this is 2 times this, for sure the two particles will meet here after traveling a distance of d and d. So now all I should know is the time. For time, I would anytime try to calculate this angular displacement phi. How are you going to do that? This distance is d, this distance is r. Sin phi is equal to d by r. D by r will be mu by bq. Bq d by m into u. I will substitute that bq d by m. I have committed a mistake somewhere.
So twice BQD by M.
D by 2. This is d by 2. Sorry. If this is total distance is d, this is d by 2. So d by 2. D by 2. So I am left with half. Sin phi is equal to half. That means phi is equal to 30 degrees. Once I know the angular displacement pi by 6, my job is done. For 2 pi, I know the time period. 2 pi time taken is capital T, 2 pi m by bq. Pi by 6, what will be the time taken? Should not be difficult. Now, after they collide, what will happen? The horizontal components will cancel out. Vertical components, both of these will add up and they will be going as a combined particle, conserve the momentum. After collision, what will happen? Conserve the momentum.
So done.
$61 60 किया हुआ है आपने hollow sphere 61 किसका डाउट है if you have done 60 give me the value of the hollow spheres mu I'll finish off this problem in 2 steps mu by L will be Q by 2L give me the mu value for a hollow sphere of radius x thickness dx d mu will be hollow sphere का बताएंगे तो मैं आगे बढ़ूंगा वरना रुको है
Q by pi r square 2 pi x dx omega x square by 2
dq
omega x square by 2
omega
x square by 2
by
2
गलत
सर ये जो डेरिवेशन है आपने बोला था कि आप OD2 में करोगे पर वो हुआ नहीं।
अरे भाई होलो स्फीयर का किया नहीं मैंने क्लास में
नहीं सर OD2 में नहीं किया था।
होलो स्फीयर पहले बोलो ना यार होलो स्फीयर का hollow sphere is a 68th problem. Now what will you do for this? Consider elemental length.
Derivation on the group I've done.
Pardon?
If you want, I can send the derivation on the group I've done.
It's okay. यहाँ तक draw कर लिया तो खत्म कर. This is r d theta. What is the radius of the ring? R sin theta. What will d mu for the ring be? dq omega radius square r square sin square theta by 2. This was for a ring. Q omega x square by 2. For a ring that was d mu. Do you all agree with that?
yes sir
Now dq will be charge per unit area 4 pi r square into 2 pi r sin theta into r d theta. Omega r square sin square theta by 2. This is d mu. 2 pi r square q omega r square by 4 integral sin cube theta d theta. Least value of theta is 0, maximum value of theta is pi. How do I solve integral sin cube theta? Write it as 1 minus cos square theta into sin theta d theta. Why do you do that? Let t be equal to cos theta. dt by d theta is minus sin theta. So dt is equal to minus sin theta d theta. 1 minus t square dt with a negative sign. Will you be able to solve this beyond this? You will get the value of mu. For a hollow sphere, L is I omega. This will be 2 by 3 mr square into omega. Divide both, you will get q by 2m. This mu which you get for a hollow sphere, use it in a solid sphere. Consider a thin spherical element. Life becomes much simple, directly integrating.
Sir, can you do 52 also?
Okay. Now, you have two plates, you have a dot. Right? A charged particle electron coming out from here will go in a circular track like this. If it should not touch the upper plate, R maximum, D maximum or Y maximum should be less than D. And you have
Understood,
done,
sir. Got it, sir. Sorry.
this was 52. Listen, feeling very tired. Next week, I'm relatively very free. Almost every day, I'll put up a doubt lecture with some of the other batch and finish off the doubts. We have magnetic field due to a current carrying wire from HCV to be done and the two assignments. I'll right now send all the assignment 2 of magnetism to all the send batches wherever I forgotten. Right? So next week, basically, we'll be completing this and DMI as well. Please be on the war footing. I'm free relatively next week evening. I'll put up doubt lectures at higher frequency. This week was very taxing. But luckily good that we completed the syllabus. Okay, now complete from your side. Next week EMI का भी doubts cover कर दूंगा magnetism के बाद. Right?
So EMI का have you sent assignments? You haven't
No,
sent
I
them?
didn't. HCV booklet first, then assignments.
Okay, sir.
Good day. Bye. Good night.
Bye, sir. Thank you.